In this video, we are going to knock out a bunch of simplifying of complex numbers, which I feel like simplifying complex numbers is kind of an ironic statement, but again, complex is just a title. So, to simplify complex numbers, I is not a variable, but you're going to treat it as one. So I have a -1 and a 3 as like terms, and I have a 2i and a 3i as like terms. So -1 plus 3 gives me 2. 2i plus 3i gives me 5i. That's my answer. Okay. If it had been a -5i, I would subtract 5i and I would move on. In number 5, there's more things happening, and this has got one piece where you have to start being careful. You have this negative sign that's going to need to be distributed here. You can physically write this if it makes you feel better. You don't have to, though. I have 3 different I pieces and 2 constant pieces. In standard form, I always do the constant piece first, the real part first. So -3 plus 2 is -1. And then I end with the i's. So 2i minus I is 1i, minus 3 more i's is minus 2i. This would be standard form. If the quiz or test or something said write your answer in standard form, and you wrote 2i minus 1, that is not in standard form. You would lose partial credit. For number 6, we're going to multiply. We can multiply whatever we want together. So it's just distributing. I'm going to have -i times 3. That's -3i. -i times I is minus I squared. Negative times positive is negative. And then I times I is I squared. But this is not my final answer. Because if we remember, the square root of -1 is what I equals. So essentially, I could have written this. This is an equivalent statement. I'm trying to simplify. So this piece right here, I'm highlighting in blue. Nothing is going to happen to that. So I'm going to keep -3i just like that. But I can do square root of -1 squared. Whenever you take the square root of something and square it, you are just going to end up with whatever was underneath that radical. So I had a minus sign. Now I'm subtracting a -1. -3i minus -1 is -3i plus 1. This is not in standard form yet. To write it in standard form, I have to put the real number first, which is the 1, a positive 1, and then there was a -3i. That is my answer in standard form. This is a little bit longer to do when there's multiplication, but you're essentially doing the multiplication just as if I was a variable. So similarly in number 7 here, you are just going to FOIL. First times first, 2 times -6 is -12. The outsides give me a -4i, 2 times -2i. 3i times -6 is -18i, and 3i times -2i is -6i squared. -12 is -12, that's kind of boring. -4i minus 18i is -22i, but -6i squared is -6 times -1. Very, very quickly, you're going to get used to I squared equals -1. It's going to be a very important part of doing a lot of these problems. So now I'm at -12 minus 22i plus 6. -6 times -1 is +6. Combine my real terms, the -12 and the plus 6, gives me a -6 minus 22i. Now number 8 is a special case here. Like it says over here, these are called conjugates. What makes them a conjugate is all of the numbers are the exact same. The only difference is that sign in the middle. They're going to be very, very helpful as we get into some more complicated things later on. So FOIL, again, first times first, 1 times 1 is 1. Outside times outside, 1 times -2i is -2i. Inside times inside is a +2i. And then last times last is a -4i squared. But what happens here is you get a 0i in the middle, and I just end up with 1 plus 4 is 5. When you multiply conjugates together, a conjugate pair is another way to call these, the imaginary parts are going to disappear, and you're going to be left with just a real number, which is kind of cool. So if you see something like this, 1 plus 2i times 1 minus 2i, you are going to end up with an answer that has no I at all. Have a great day, everybody.